Hi QA folks, welcome back to my channel. Today let's talk about an interesting topic, design patterns. These are the topics which are really helpful if you're looking to clear interviews for SDETs or QA automation, or just if you want to deepen your knowledge in QA automation. See, these are the engineering principles used by SDET leads or QA automation leads to build a framework which are scalable and robust. So today is more of a theory based video. If you really understand these concepts right, this will make sure you stand apart from the average QA engineer crowd. What are design patterns? As per the definition, design patterns are standard ways of building automation frameworks to make them scalable, maintainable, and easy to extend. See, think of it like a rule book designed by experts who are experts in designing automation frameworks in general. So they have given set of rules. If we follow those, the frameworks which we build can easily be scalable, and it can be maintained at a larger level. See, you may think I can build my framework in my own way. How does it matter? Yes, it does not matter as long as the framework is is actually built to solve a basic problem. If you want to extend the framework to build to extend the framework to solve a bigger problem or problem across domains, or if you hire some new junior QA, he wants to come and understand the framework, so it is going to be very difficult. So that is the reason usually across industry people try to follow certain standards. Those are called design patterns. If you see here, it is like a reusable solution to a recurring problem in software design. See, reusable solution means these are actually been used by multiple organizations, and they have tried to solve recurring problems. Because right, if you have quite experience in software industry, you have seen most of the problems feel recurring. So if we have a predefined rule book to solve predefined problems, it's going to make our lives very easy, and also the process also runs very smooth. These are the commonly used design pattern techniques in QA automation framework to design the frameworks: page object model, singleton pattern, factory pattern, builder pattern, facade pattern. While there are many more design pattern techniques exist, let's stick to these five in this post, because these five are the most commonly used design pattern techniques across the industry while building QA automation frameworks. Let's start with page object model. This is the gold standard for UI automation framework. If you pick any UI automation framework across the industry, they would be most probably using page object model as the base design pattern, because it separates the test logic from the UI locators. See, instead of hard coding our UI locators, here what we do is we actually create separate page classes for each of the pages what that comes across in the application. Here, imagine you have 50 test scripts in your framework. Each test script have this login functionality hard coded like this: driver.findElement by ID login button. Suppose tomorrow if developer changes something with this ID, then we'll have to end up changing in all those 50 test scripts. So instead of that, if we follow page object model approach, then we only create one login page class. There we define this driver.findElement by ID. If something changes tomorrow, we only have to go and just modify that one page, and we can just create the object of the login page class and use that in our all 50 test cases. So we don't have to end up changing in everywhere. We just have to go and modify in one place. So this is how the page object model provides scalability and very robust design to actually build UI frameworks. Let's see a simple practical example. I've given two examples here, before and after. Before using page object model, suppose you have a test case here called login test. Inside that, if you see, I'm using the XPath directly to find the username, password, and then click on the button, the login button. If something changes, say suppose if you have 50 test cases like this, and everywhere if I use this login functionality, and if something changes tomorrow, I have to go and modify in all 50 test cases. Instead of that, if we use page object model approach, where we create a separate login page class, inside that we define all the fields which actually come up there, and then the actions on those fields. Suppose we have username, password, and login button, and we have captured the XPaths for all of these. And what are the actions on those? It is mainly entering the username, entering the password, and then clicking. So if we define these, now tomorrow if you want to create one more test case using this login functionality, just go and create an object of that login page and keep calling the methods. So if something changes, We only have to go and modify in this one login page instead of touching all 50 test cases. Next is singleton pattern. This is the second most commonly used design pattern while building QA automation framework. Singleton pattern basically means creating only one instance of a class. Singleton pattern ensures only one object is created basically throughout the execution of the application, and the same object will be reused every time when it is required. See, in terms of QA, when we create WebDriver objects, right, so we don't have to actually create it multiple times, or when we want to create a new database connection, only one time will actually be mostly sufficient. Or when you want to read the configuration files or load the logger files, see, if we try to create multiple instances during these processes, it may lead to performance issues. So the best way for this is to follow the singleton pattern. See, in this problem I've shown, without singleton, every test might create new browser instance. Imagine if we have hundreds of tests and all of those creating new browser windows, that would lead to performance issues. So the only solution would be for this is singleton, which ensures only one browser instance is created and the same instance is used for the execution of 100 test cases. Let's look at a simple practical example for singleton. I've given two examples here, before and after. Let's look at the before. Say before we have two test cases, test A and test B. If you see, if you go inside test A, it is creating a WebDriver instance for Chrome driver and executing the test code and quitting it. Same when test B starts, it again creates an instance of WebDriver for Chrome driver and starts executing. So same way, if you have 50 test cases, it's going to create the WebDriver instance for 50 times, which might lead to memory and performance issues. Let's see how this can be solved. Let's see how this can be solved using singleton. As I explained before, singleton is basically meaning only one instance of a class. So how to achieve that? To achieve that, we need to have a private constructor. Say we have a class called a driver manager. Inside that, I have created a private constructor. Private constructor means no one can actually call this constructor from outside, hence no one can create the object at will. But we need a web driver instance, right? So for that, let's create a public web driver get driver method. Why public? Because if someone wants to create a web driver object, they should be able to getting the access. That's why I've kept as public. So inside this, the logic is, if the driver object is null, if there is no driver object created, we'll create a new driver object. Else, if it is already present, let's just return whatever is already active. So in our test case, suppose the test case A, just like before, is creating a WebDriver instance. First time we'll just call this getDriver method, comes inside, it checks. Yes, the driver is null because there is no prior instance of the driver. So it creates a new driver object, returns the driver, and it comes here, it executes the test code. Same way, when the test B starts, it again tries to create a new WebDriver instance. Same, it is going to call the getDriver, but as the driver object is not null, it is already present because it was created during test A, it was not destroyed, right? So it is still active. What happens? The else block gets called and it just returns whatever the active driver present. So in this case, the driver object got only created once and it has been getting used in multiple test cases. The next design pattern is factory pattern. Most of the QAs usually get confused between factory pattern and singleton pattern. So once I explain this factory pattern in detail, maybe that might clear off the doubts between the similarity of these two. See, factory design pattern is a creational design pattern that usually hides the creation logic and provides a common way to create the object. See, instead of creating objects directly, we just ask the factory pattern to create objects for us and it creates. In QA context, if I have to give an example, so usually we have to test our test cases across multiple browsers, say Chrome, Edge, or Mozilla. So in that case, we don't have to write different logics to create each of the browser's instance. We just create one logic and make it a factory pattern, and we just provide input, say Chrome, it gives us back the Chrome driver. Or if we provide input like Mozilla, it gives us back the Mozilla driver without exposing how the creation logic has been written. So now what is the difference between singleton and factory is that in singleton, usually we restrict the number of objects created to one. But in factory, that's not the case, right? Here, based on the input, different types of objects are created. See, as I told in QA automation framework, Factory pattern is most commonly used when you want to create WebDriver instances to handle different browsers, or even sometimes when you want to test across multiple environments. So based on the input, like I said, Chrome or Firefox, the factory returns the correct driver instance. Now, why this is called as factory? Because see, just like a real factory produces different products based on the input, a software factory pattern creates different objects, like I explained, based on the some condition, some input condition, without exposing how the objects are created. So let me show you one practical example, so that would give you even more clarity on the factory pattern. Here I have shown before and after. Let's see without factory pattern how it works. Say we have a test case which has to be executed across Chrome, Firefox and Edge. So here I am doing get driver, WebDriver is equal to new Chrome driver. This is hard coded. So this will give me the Chrome driver instance. So if I want to again execute this in Firefox, I have to change this logic because it is hard coded. Again, if I want to do this in Edge, again I have to go and change this. So this will not work right if your framework is very exhaustive. So now let's see how this is solved using factory pattern. See, in factory pattern, what we do is we create a class called driver factory, and using a method inside that which takes an input called browser type. Say if you want to pass Firefox, Chrome or Edge, let's take that as input and see what logic is written inside. See, first we are defining WebDriver driver. Now we are using a switch case where if the case, okay, basically the case is the browser type. So if the case says Chrome, if you pass it as Chrome, it creates driver is equal to new Chrome driver. Or if you pass it as Firefox, it creates a Firefox driver instance. Or if it is Edge, it creates Edge driver instance, and it just returns the driver object. Let's see how this is used in a test case. So in test case, say if you want to test on multiple browsers, okay, you want to first get the browser right. So what you do is config, say suppose if you have defined in your config file browser is equal to Chrome, so you're reading that property here. So the Chrome will be passed WebDriver driver is equal to driver factory dot create browser, and passing this Chrome here. It goes to this create browser method, and Chrome will be passed inside this. In the switch case, Chrome gets activated and the Chrome driver instance is created and it's going to be returned here. So now based on the Chrome driver instance got created, our test case will be executed. Same way, if you change just in this one place, if it is Firefox, then the entire test case would run on Firefox browser. The next design pattern is builder pattern. So what is builder pattern? So builder pattern is mainly used when creating an object needs many details and creating it in one step become very confusing. See, instead of creating an object in one go, builder pattern actually helps us build the object step by step. And why do we need this builder pattern? Imagine you're creating something where some details are mandatory and some details are optional, and not every test needs all of these details. So passing everything at once becomes messy and hard to maintain. Oh, okay, if I have to explain in terms of QA, say in automation testing, we often create test data or API request bodies, or you can even sometimes configuration objects, right? Where not all details will be passed every single time. So builder pattern actually lets us create only what we need and ignore the rest. See, how do we have to remember it? If object creation feels too complicated and your constructor has too many parameters, that's when your builder pattern comes into picture. Usually, explaining just through theory might not give a clear picture. So let me show a practical example of builder pattern. So please stick with me because this is a slightly complicated example compared to whatever I've shown before. See, before using builder pattern, suppose we have a user class which has three parameters: name, email and age. Okay, see, in a practical example, you might have hundreds, but for the simplicity's sake, I've only taken three. Now, whenever you want to create an object of this user class, you have to call the constructor which should take three parameters. See, here it's just three, so we can pass these three values and create the user object. But say if it has 20, then you tend to miss one or two, values, or might send wrong values. So this is not very user friendly. See, as I've written here, it is very confusing and error prone and easy to mess up the order also, right? Now, how do we solve this using builder pattern? So let's take the same example with a user class which has these three parameters: name, email and age. and it has a private constructor user. So why it is private? Because this should not be accessed from outside. But if you notice closely, inside this private constructor, I'm calling something called builder object. Now what is builder? So builder is another class which I have defined inside the user class, which has three setter methods: set name, set email, and set age. And the builder class also has the same three parameters which the user class has. So why this is done like this, I'll explain in some time. But if you notice here, inside the builder class, I have these three methods as I told. Set name, which will take any input sent by the user. Suppose if user is say Nirush, this will be set to this private name variable, and that will be stored in the builder object. See, this return, this is basically we are returning the builder object. If you see here, we're catching this value with the builder classes object. So now at the end we have one more method here called build. So what does this do? I'll explain when I explain the test method. So let's go to the usage. Now if you want to create a user object, what you do is you do user is equal to new user is what basically we do, right? But we are using here dot build. So what this line does is basically this will create a builder object. User dot builder is basically we are calling the builder constructor here. So builder object is created, and using that object we are calling this set name, and we are passing John. Set email, we are passing this email, and set age, we are doing this. Ultimately we are calling dot build. See, these three are self-explanatory, where the set name will be called and the value will be stored in this variable, and that will be carried by the builder object using this line of code. So now the builder object will have all these three values, and ultimately when we do dot build here, those values will be transferred to the user object. So yeah, this is how it works. And if you want to just send some optional fields, you can just pass these two values also and just build. You don't have to always pass all three values. So in this case, age is not passed. I hope I have tried to explain this complex topic in a very simple manner. So if you have any doubts, please comment down below. So the last design pattern for the day is facade pattern. Facade means simple face or interface to something complex. So the facade design pattern provides one simplified interface that hides complexity of multiple underlying systems. Okay, see, why do we need facade design pattern? Because in real application, what happens? One feature often depends on many classes working together, which we don't want to always expose. Like, calling them directly makes the code very hard to read and hard to maintain also, and it makes it very tightly coupled. See, in terms of QA automation, if I have to explain, usually in automation frameworks, facade commonly is used to hide multiple Selenium actions behind one method, or simplified complex workflows like logging, booking, checkout. So those we don't expose. We just expose one unified interface which hides all of those implementations. So because if you want to call certain number of steps multiple times, instead of calling them multiple times and make the code very tightly coupled, we'll just wrap it under an interface and keep calling that interface wherever it is necessary. If it sounded very simple and unclear, let's look at a practical example. Like before, I have given two scenarios here, before using facade pattern and after using it. So let's see what's the problem we face without using facade problem. So we have a test case here which says test export order. See, to complete this test, actual test verification is here. So we need to do all of these steps before and then go to our test verification. So what are these steps? Driver.get, find elements, username, password. First you log in and then go to orders, give start date, end date, filter, and export. Once you export the orders, your actual test verification starts. Suppose you have another say 5 to 10 more test cases like this, which all requires this export order steps to be written multiple times. This is not a very good design of framework, right? Let's see how this can be solved using facade pattern. See, after that, what I'm doing is I'm creating one class called order facade. So inside that, I am declaring the driver variable, and see, these are all the facade methods. So to order, I've created one method specifically to just place the order. What it does is it will log in, give username, password, login button, navigate to orders. Yeah, the orders are done. Next, filter orders. This method will just go provide start date, end date, and filter the order. Next, we have export report, which just exports the report. Now we have these three basic methods defined. Then we have one single method to complete the workflow, which is called export order report, where we are calling first navigate to order, then filter order, then export order. This method takes all the necessary inputs for all of these methods required. Now what happens in my test case, if I want to test the export order like before what we saw here, test export order, instead of writing all these lines of code, what I do is I just call this one method by creating an object of this order facade class, which we created here, order facade. If you see, using that object, I'm just calling this export order report, which we created the last method here by sending all the necessary parameters as input. Now only calling one method will actually solve completely all the steps like logging in, filtering, and then exporting the order. Once this is done, we can actually call our test verification. So same way, if we have multiple test cases, we just have to call one method. See, this is how it has been completely done. Remember, guys, good code just works, but a great code will last for a long time. So, these design patterns are not just interview topics or textbook theory. They are thinking tools that help you design better automation frameworks, handle change gracefully, and scale your framework as product grows. If you want to move on from writing test scripts to designing frameworks, this mindset is mandatory. As I always tell, if you want to stay apart from the average QA folks, so you have to learn all these concepts and step up your game. As always, for useful contents in QA and AI domain, please follow my channel, and thank you for sticking up with me till the end.